Welcome to today's lecture over scientific notation. So the main goal of this is to quickly summarize what is it, why do we use it, and then how do we convert between standard notation, which are these big, huge, giant numbers, back down to scientific notation. So again, first, why do we use it? The purpose of scientific notation is to act as an abbreviation for these giant numbers. This first number right here is the current distance as of September 1st, 2016 at 2:15 p.m. Current distance of the Voyager 1 spacecraft. This down here, this very small number is the width of a proton in meters. They're giant numbers that we in science tend to use quite a bit, so it's more advantageous for us to use a different way than just writing out all these zeros. So scientific notation has three main parts. First part is our coefficient, which I'm going to name n. This is our coefficient. Second part is our base, which is times 10. Our base is always 10. And then our exponent, which I'm going to call e to the e power. That's our exponent. Now, rules for our scientific notation. First rule is that our coefficient must be between 1 and 10. Must be between 1 and 10. So that means that while we're thinking about math, we'll use our inequalities, which means that it must be greater than or equal to 1 and then less than 10. So that means it can be 1, 1.1, 1.11, 1.1111, 9, 9.99, 9.999, but not 10. So coefficient must be between 1 and 10. Next, our exponent. Must be a whole number. So it's easiest for me to tell you what's not a whole number. What are not whole numbers are either decimals or fractions. So it cannot be a decimal or fraction, must be a whole number. And it must move our decimal place to satisfy rule 1. All right. And rule number 1 just means that we're pushing the decimal place over so that our new number is between 1 and 10. So this number right here is got an imaginary decimal point right there, and we're going to push it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So this is 2 times 10. We pushed it over 10 places to the left, so that's going to be a positive 10 kilometers. Now again, like we said, this is an abbreviation. These two numbers have the same value. So when I multiply 2 times 10 to the 10th power, that's adding 10 zeros behind it. So this is that same number represented in an easier way to read, so that we don't have to read 10 zeros after it too. So if we move the decimal left from standard notation, which I'm going to call SN, use positive exponents. So just like that one, we used a positive exponent to push the decimal over to the left. Now, for our next example, we need to move the decimal to the right. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and it needs to be between 1 and 10, so I'm going to do that 15th spaces. So this is 1 times 10. Again, we moved it to the right, so that means negative 15 meters. So, rule number 2, if we move the decimal right, use a negative exponent. Because again, these two numbers need to be the same. So, as we recall from lecture, this is the same as dividing by 10 to the 15th power. And when I divide 1 by 10 to the 15th power, I get this giant number again. Now, what if there's more than one number? And for example, we have 323,000. And we need to convert that to scientific notation. So we've got our imaginary 0 right there. We move it 1, 2, 3, 4, 5. 5 places to the left. So rule for moving the decimal place to the left is use a positive exponent. So that is going to be 3.23. We write all numbers that are significant. So write all significant digits in our coefficient. And then the rest drop out. So the real purpose behind scientific notation is to get rid of our leading or lagging zeros. So our new number is 3.23 times 10 to the 1, 2, 3, 4, 5th power. There we go. Hopefully that's a good review summary for our test coming up. Good luck and